In this video, we're going to do pre-responses for Chapter 4. So we're going to start on page 18 on 2009, number 5. And so in this problem it says let f be a function that is twice differentiable, and the table above gives values for f on the interval 2 to 13. And the first thing it says, estimate f prime of 4, show the work. So to estimate, that's an instantaneous rate of change. You use an average rate of change, right? So you don't have to write this down, I'm just making notes. Anything I write on the other sheet of paper is what you would have to write down. To estimate f prime of x, which is the instantaneous rate of change, you use the average rate of change, which is f of b minus f of a over b minus a, or if you prefer, y2 minus y1 over x2 minus x1. And so how do you know which two values to pick for a and b? You just want to capture 4. So we know 4 falls right here, so we're going to use those 2 points. So for a, we're going to say that f prime of 4 is approximately a squiggle sign, because we're estimating it, the average rate of change using those points. So f of 5 minus f of 3 over 5 minus 3, which if this part, writing it in terms of f, you don't technically have to do that. You could jump to this part, which is going to be f of 5 is negative 2 minus 4 over 5 minus 3. You could just write that, but you do need to show one point on these questions is this difference quotient. So don't do anything in your head, write this out, and then you can simplify. So that would be negative 6 over 2, which is negative 3. So f prime of 4 is negative 3, and then let's see, do we have units? No, so we don't need to write units. So then part B says evaluate this integral. So I'm going to go and write this integral down. 3 minus 5 times f prime of x dx. So how do we evaluate a definite integral? Calculator, but this isn't a calculator question. Plus you can't type f prime of x in a calculator. Area, if you're given a graph, but we don't have a graph. And so our other option is fundamental theorem. So to use fundamental theorem of calculus, you got to first get the antiderivative. So let's think about getting the antiderivative. The antiderivative of 3 is just 3x. Now, how do we do the antiderivative of this? Just think about it in terms of what's the antiderivative of f prime. Go backwards. You would go back to f. Now, what do we do with this 5? That's a coefficient, and when you do integrals and derivatives, you keep coefficients, right? If that was 5 cosine, then it would be 5 sine. So that's still going to stay minus 5, but now the antiderivative of f prime is f of x. That is your antiderivative. And write your boundaries. So now we can do f of b minus f of a. So f of b, we're going to plug in 13. 3 times 13 minus 5 times f of 13. That's f of b minus f of a. 3 times 2 minus 5 times f of 2. Out of parentheses since I did the other one. Okay, so 3 times 13 is 39. Minus 5 times f of 13, you go to your table, right? Because this is f and this is f. That's why we took the antiderivative, so now it matches. F of 13 is 6. I'll keep that in brackets till I'm ready. Minus 3 times 2 is 6. Minus 5 times f of 2, which go to your table, is 1. So we have 39 minus 30 minus 6 minus 5. So we know this is 9. 6 minus 5 is 1, so 9 minus 1, which is 8. That would be your answer. So for C, it says Use a left Riemann sum with subintervals indicated by the data in the table to approximate the integral from 2 to 13. Check those boundaries. Okay, don't just do the whole table. In this case, it does go from the beginning to the end, but just be careful because it doesn't always. You can show the work. So how do we do a left Riemann sum? You're going to be doing rectangles, and you do length times width. Or I think about it, width times height. So the width is going to be this distance between the x values. Now, because it says subintervals indicated by the data in the table, that means it's not equal width. So we're not going to use that formula, b minus a divided by n. We're just going to go following from here to here, here to here, here to here, and here to here. So we should have 4 rectangles. And so how do we do this for a left Riemann sum? So the width is going to equal from 2 to 3. That's a width of 1. And then you use the left side y value as your height. So if I'm going to write this out, my Riemann sum would equal, my first width is 1 times my left y value for that was also 1, plus, now the next width, 3 to 5. You can think about subtracting. 5 minus 3 is 2, and use that left y value, because it's a left Riemann sum. So that's going to be 2 times 4, plus the next one, 5 to 8, would be a width of 3 times negative 2, and you do use the negative, plus the next one would be 8 to 13, which would be 5, and the left y value is 3. So you're never going to use that far right one. And if it was a right Riemann sum, you would have been using the right values, and you would have never used this far left one. So this last one is 5 times 3. And so then we can get what this equals. So that would be 1 plus 8 minus 6 plus 15. So what? 16 plus 8 is 24. Minus 6 would be 18. So what did it ask? That was our Riemann sum. We're using this Riemann sum to approximate the integral, right? Because what is an integral? It's the area. So this area is approximated with this area. Because, right, our rectangle is going to go a little over or a little under. But now we know the integral from 2 to 13 of f of x is approximately 18. Okay, so for D, this one's kind of weird. It says, suppose f prime of 5 is 3, and f double prime is less than 0, so it's negative. Anytime it says less than 0 or greater than 0, I just write negative or positive. For all x values in the interval 5 to 8, use a line tangent to the graph of f at 5 to show that f of 7 is less than or equal to 4. And then you're going to use a secant line to show that f of 7 is greater than or equal to 4/3. So let's just focus on the first thing. First it says use a tangent line to the graph at x equals 5. So right there, if you get overwhelmed with all of what this is saying, just go ahead and get a tangent line using that x value. And then we'll go from there. So a tangent line, we know we use our point slope form. And the x they give you that you're doing your tangent line value at is your x1. How do we know y1? It's going to be the y value, right? F of 5, which we're going to use our table. The y value that goes with that x value is negative 2. And your slope is the derivative, f prime at that x value. Your y1 is the original function at that x value, and your slope is the derivative at that x value, which they gave you that. F prime of 5 is 3. So we can write our tangent line. Y, since it's minus negative 2, I'm going to make it plus 2, equals 3 parenthesis x minus 5. And now you can leave it like that, but because I'm going to use this tangent line now, it says to show that f of 7 is less than or equal to 4. So what that's saying is we're going to now find f of 7. We're going to approximate f of 7. So don't worry about this less than or equal to 4 yet, but that means your x value is 7, correct? So we're going to use our tangent line to approximate f of 7. So we're going to plug in 7 for x. And you could do that here, or you could solve this for y. It might be easier. So let me go ahead and move this 2 over, and I'm going to distribute my 3. So that's 3x minus 15, and then I'm going to do minus 2. So my tangent line is 3x minus 17. So now I'm going to plug in my x value that I'm trying to approximate. So y equals 3 times 7 minus 17. So what is that going to be? 21 minus 17, which if you need to go to the side and do some basic math, 21 minus 17 is going to be 4. Okay, so what is this talking about? It's saying show that f of 7, now we know it's less than or equal to 4. But that's because our tangent value is 4. So this, we use a tangent line to approximate the real value. So let me give you a picture for this to understand what we're doing here. So if we think about what they tell us about our function, we know that f prime of 5 is 3 and f double prime is negative. Why did they tell you that? What does that tell you about your graph? That it is concave down. So if you just think about a concave down graph, I'm not even going to try to make sure it's the right points. And now what we know is that when x is, we're talking about when x is 7, right? So let's just say this is 7 right here. We'll make that an x-axis and a y-axis. If we draw this tangent line, 3x minus 17, now that was the tangent line at 5 though, right? So that is tangent line at 5. So then we're going to come over here at 7, and this y value on your tangent line is at 4. Right? We created a tangent line to 5. That's where it crosses. It shares a point with your actual function. And then we went and plugged in 7. And we got a y value of 4. So what does that mean for this actual y value on your function, f of 7? We can see now that the f of 7 is less than 4. It's lower than 4. Right? Why is that? Because it's concave down. Our tangent line gives us an over approximation. I think we wrote that down. So what we'll say is, because our tangent line equals 4 at x equals 7, and our function is concave down, we know that is an over approximation for f of 7. Which is the same thing what they were saying here. F of 7, if 4 is an over approximation, then f of 7 is less than or equal to 4. So I'll put comma, f of 7 is less than or equal to 4. So hopefully that picture kind of helps. That was the first part. Now if you do the second part, it says use a secant line for this interval 5 to 8 to show that f of 7 is greater than or equal to 4/3. So we're getting a really good, if we can show these two things, we know it's less than 4 but greater than 4/3, we're getting a real close value for what f of 7 should be. So what do we know about a secant line? Is you use 2 points. And you use the points from the interval. So we're going to use 5 and 8. So I'm going to come back up here. So you're not doing a tangent line. we're going to find the slope for our secant line. So our point for 5 is 5, -2. Our point for 8 is 8, 3. So we're going to find that average rate of change. So the average rate of change would be 3 minus -2 over 8 minus 5, which would be 3 plus 2 over 8 minus 5. So 5 over 3. And now we're still using point slope form. This is your slope of your secant line. And then you can use either point, right? Because for point slope form, this x1, y1 is just any point that the line goes through. So you can pick either of those points. I'll go ahead and just do this first one, make this x1 and y1, and write my equation. So again, it's minus y1, so since my y1's negative, I'm going to make it plus 2. My slope is 5/3, x minus 5. That would be a secant line. And so it says, use the secant line to show again that talking about f of 7. So your still x value is 7, and we're going to find what would our y value be on our secant line. So if we plug in 7 for x again, just like we did to our tangent line, or you know what, let's get y alone again, it might be easier. I'm going to distribute this, so 5/3 x minus, if I multiply this, it would be 25/3, and then minus 2, which is kind of messy. Maybe it would have been easier to not simplify it, but oh well, I already did. Now I'm going to plug in 7. So what does this become? Y equals 35/3 minus 25/3 minus 2. So I'm going to go ahead and simplify my thirds. 35 minus 25 is 10/3 minus, I'm going to make this thirds also. So I'm going to put that 2 over 1 and multiply it by 3 to get a common denominator. So that is the same thing as 6/3. Which now I can subtract these. 10 minus 6 is 4/3. So we can see that again they're comparing it to this. This was the value from your secant line. So how do we know that f of 7 is going to be greater than this value? Well, again, let's think about the fact that it's concave down. I told you that for a reason. And what you did is here's 5, here's 8. 5, you know what, I didn't probably do the right y values, but it was increasing though, so let's just make it look like this. I understand that this y value should have been a -2. But regardless, if it's concave down, then when you draw your secant line, and then let's say we used it to approximate 7, our tangent line value for 7 is right here. I did not do those evenly. It's supposed to be right underneath each other. Ignore that one. So this is a y value of 4/3 where 7 hit the tangent line, and we can see that that is under whatever the actual value, this y value is f of 7 on your actual function. So we can see that f of 7 should be greater than 4/3, which is what that said, because your function is concave down. So we'll say because our secant line equals 4/3 at x equals 7, and our function is concave down, we know that is an under approximation for f of 7, which was the same thing as saying under approximation that for, how did they word it? F of 7 is greater than or equal to 4/3. Which is what they said here. So this is a great question. but I would not stress about D. You should understand how to create a tangent line, and that if it's concave down, then your tangent line is an over approximation. I have not seen this come up a lot other than this question, but hopefully it challenged you. And I think I'm going to do the next few responses in a different video.